Namaste. Hope you are doing well. Today we will tackle the first problem of ISI MSTAT 2021 PSB. And yes, it's a real analysis problem with an element of trigonometry involved. Quite simple. A function is given and the question is asking which points in the domain would make that function continuous and differential. Second part, which points would make it differentiable. Now, this may be intuitively quite clear that just see which points have this thing equal to this thing. But there is a subtle nuance in the sense you have to write things properly. And it's difficult to visualize rational or irrational in a function, right? Because every rational is surrounded by infinitely many irrationals, and say every irrational is surrounded by infinitely many rationals. So we have to go about a rigorous way to write things. Essentially, this could have been a PSA question, but because you would have to write things, it qualifies as a PSB question. Now, so how would we make it easier for ourselves to check for continuity? We would have to use trigonometric identity to simplify the connection between this side of things and this side of things when the time comes. So this is a standard identity. And from here coming to this is clear if you think about sin square x plus cos square x equals to 1. Now, the important part, the heart of the problem according to me, how to write things, how to write the continuity and later differentiability. This definition will come in useful. There are multiple definitions of continuity. One is using sequences. It says that for x naught is going to be continuous if any sequence in the domain, which is the real line, any sequence in the domain that converges to x naught would give the convergence of the functional value as well to the function value at x naught. Okay, with this, let's start. Now, we'll try to take the point of continuity and back calculate things. We can start by taking x naught as a rational point of continuity, and so things would be around here. If the sequence itself is completely rational, then it would be just like checking whether this thing is going to this or not. But it does because cos is continuous. So the real challenge is to check for sequences that have irrational elements in them. That would be involving this side of things. So this is going to happen, obviously, if and only if this is going to happen, because the left hand side is involving irrational elements, and by definition of the function we are over here. Because sin square is continuous, the limit can go inside, and by the definition of construction this thing is going to happen. So we have this, then we can use the trigonometric identity to get this, and simple, you get something in terms of sin square x naught. Now note that we started with this, that suppose x naught is a rational point of continuity. This does not guarantee us whether x naught is going to be a rational point or irrational. But even if x naught is irrational, similar maths would yield the same result. Instead of sin square this side you would have cos, and instead of cos this side you would have sin square. So it doesn't matter whether x naught, the point of continuity, is rational, irrational. The method to get to it and back calculate things is going to be the same. Now we would want the answer in terms of x naught only, remove the sign, so we take the sine inverse. So this is the solution. But is this the only solution? No, because trigonometric functions have periodicity associated with them. So a general solution when sine inverse is involved is this. And because we have two solutions, so there will be two sets of general solutions. We can club this information, these two, and this information as well. Here k, by the way, is any integer. And when we club, we get this. So not only are these two the solutions, the points that are going to make the function continuous, any point that is having this kind of periodic structure associated with pi, say pi plus c, pi minus c, 2 pi plus c, 2 pi minus c, that's also going to be a point of continuity. So this is the answer for part A. Now coming to differentiability. Once again, it may be quite intuitive to just get the derivative of this and the derivative of this and then do some matching, see. But we have to be rigorous in our writing because it's a PSB question. And to make it easier to check for differentiability, only look for points that are continuous, because continuous points are the only ones that can be differentiable, if at all they are differentiable. No non-continuous point would be differentiable. And we would use a similar sequence-based definition of differentiability, wherein if we have a sequence in the domain, real line, that converges to a point x0, then that point x0 would be said to be differentiable if this limit exists and is the same for all sequences that we take. We have this. Now let's proceed. Notice that we can tweak things and write it like this to get to a form that I am sure many of you would be familiar. The standard definition of differentiability, perhaps for many of us. But it was necessary to start with this and then come to this, because the provision to encapsulate rational and irrational that happens with the sequence definition. Now, suppose x0 is irrational, and once again, it's just it's one of the two things that you can consider. The point x0, whether it's rational or irrational, doesn't exactly matter, but the math would be similar. But just to have concrete structure, you would have to start with some supposition. Suppose it's irrational and you have any irrational sequence going to that point, then you would want this limit to exist. But this is anyway, the numerator is going towards 0 and denominator is going towards 0. So you can use L'Hopital to get this, basically differentiation of this. And then you take the limit going to 0 and you would have this. Now let's talk about when it's a rational sequence that we are considering. The rational sequence is going to x0. So this thing would come up. Again, because of the continuity angle already associated, the numerator overall is going to go to 0. So denominator is also going to 0. It's a 0 by 0 form. We can use L'Hopital and differentiate this to get this. So did you see? It's basically a formulation of intuition only. The derivative of this is going to be this. The derivative of this is going to be this. But x0 already has a structure which is involving this thing. And the only way that these two things would be equal is when sine to x0 is 0. And that cannot be because of the structure that x0 already has. And even though we started with if x0 is irrational, while writing the answer, you could end with something like, even if x0 is rational, similar math would show that the corresponding limits for different sequences converging to x0 do not match. And that's why there is no point of differentiability. Of course, you would have been tricked by just checking for this and getting the value at which sine to x0 is 0. But we have to start with this set only because it has to be continuous first and then differentiable. Okay. That's it. You have the points at which they are continuous and the points at which they are differentiable with null set. And some base to build your base is, this question was quite intuitive from the beginning itself. maybe if it was a PSC question, it would have just taken 1 minute. We would not have had to write rigorous math behind this. So we had to sort of document our intuition properly. I don't know why this came glitch. And perhaps questions like this, where we sort of already have a very good grasp of what the answer, but don't know how to write it, if we can sort of learn how to document it further, then maybe we can also develop our intuition better. So we should practice writing out our intuition. That's it. And if this was helpful for you in any way, then the request this time is to write down or document a rational solution to a global problem which seems very irrational in its existence. It could be a hunger crisis or whatever. Write your mini thesis. You don't have to share it with anyone unless you want to, but think about it. Think about solving real life problems. And take care. Hare Krishna.